camera and microphone, so I gotta try to see if these levels work out or whatever else. Was that showing the webcam, by the way? So, today is February 2nd. I'm not going to drag the screen down. But we ended here yesterday in 12.3. So check this really quick just to remind us. When is it that I will get one unique triangle that no matter how I would try to change how to draw it, it's going to be the same triangle? Moms?
2 angles and a side.
2 angles and a side. Now, does that side need to be in between those angles that I've been given?
It can be either.
So what did we say about when we're given 2 angles? Because this tells me right down here that, well, where's my starting? Don't do this to me today.
That's not true.
What happens when you're given 2 angles in a triangle? I love Monis's voice, but anybody else got their brain turned on this morning? No. When you're given 2 angles for a triangle, what is actually happening? Ozzy?
You're being given 3 angles.
How is it that you're given 3? They only told us 2.
All of them have to add up to 100.
Ah, we know our triangle sum rule, or theorem, but really we can just say it's a rule. You guys know that theorems are like rules, right? So a theorem is something that has been tested and checked and made sure that it does hold true. So our triangle angle sum theorem tells us everything has to sum to 180. So if you did not notate this on your paper somewhere, you can highlight this and then highlight the fact that 2 angles really gives us all 3. Because we can calculate the third. So then this side, whether it's included in the angles they gave us or not included in the angles they gave us, doesn't matter because it will end up between 2 angles that we know. Biggest thing to get through your brain here is when I give you 2 angles, I really gave you all 3. You just have to do a tiny bit of math. Any last questions remaining from yesterday's lesson?
Are we finishing now?
So I mean, we already talked about this, got it? Because if I give you 2 given angle measures and the length of a not included side, we can make it included by finding that third angle. So now, let's go deeper into 3 dimensions and talk about food. Sorry, I know you're the morning class, that's kind of rude, but we're going to talk about food. So, like that video just showed us, food has some pretty common characteristics, one of which being it's 3-dimensional, right? It's got length and width and height, unless you have that really like weird stuff that like flattens all the way, and then it's still 3-dimensional, even though it gets super flat. So in their video, they talked about 2D, but you have to kind of imagine that the width or the depth goes away. So if we have a block of cheese, you gotta realize, because I always argue with kids every year, so I'm trying to like stop the argument. I'm not actually saying we're going to get 2D shapes. We are imagining what 2D slices would be created when we cut a shape a certain way. So I have this giant block of, let's assume it's probably Velveeta, right? Anyone ever see the big old block of Velveeta government cheese that makes you kind of because if I can push into cheese like this, it's kind of gross. But off of Velveeta, giant block of cheese. So it's square on the end, but then it's long. So that is a square prism. We're going to talk more about 2D, 3D shapes in this next chapter. But a prism is any shape that starts at one shape and ends at the same shape on the other end. Starts at a square, ends on a square. Yeah?
Is it possible to make them 2D shape? Like out of, like, hold it in your hand?
So imagine that if you have a stack of Kraft slices, that's your 3D shape. If I take one slice, that's a 2-dimensional slice of the 3D block. So it's still 3-dimensional. That's the hard part of like relating that we're going to make 2D shapes because our world is a 3D world. You can't just keep him here. If he stays in here on his own, that's fine. You can't just commandeer your solver all day. You're good. I love him. If he wants to come hang out with me, that'd be great. But, so, for anyone in the video thinking that's weird, Saul is our therapy dog. So when we talk about food turning into 2D, you kind of have to use your imagination a little bit. It's still technically a 3D shape, but we're looking at what 2D shapes would be created. And more so, it's easier to think about what 2D plane did my cut make? So imagine that we all have lightsabers, right? Who would love a lightsaber? Yeah, I just carry it around everywhere. If a door was locked, I would just lightsaber it. It'd be done. So we have this block of Velveeta, and now you can think of a cheese cutter, but I'm going to think of my lightsaber. We lightsaber straight down through it. Now this plane on the end that you created with that slice, what we're asking is what is that plane going to be, or what is the slice that we just made, going from front to back. So if I bring that shape over, what kind of shape is it going to be when I slice through this direction of the block? Sean? A square, so I can draw it out here, and what is it going to measure? So we look at the dimensions of the original 3D shape.
4 by 4.
It's going to be 4 inches by 4 inches. Now I have a question beyond what they ask. What if I'm making a giant hoagie? I used to work for Jimmy John's, by the way, in case you didn't know that. Best sandwiches ever. Subway's got really bad health standards. If you want to talk about that sometime, talk to me at lunch. Because I had a friend who worked at Subway. Jimmy John's is way better. So it is, but it's better. So Subway will freeze and thaw their meat multiple times. Jimmy John's cuts theirs fresh daily. So, well, still, we got it all. Talk to me at lunch. My lightsaber, now I used to slice this direction and get a big old slice of cheese. Now let's assume we had not sliced the end off. So I still had the original dimensions of 4 inches by 4 inches by 13 inches. So that big old slice that I'm making for my hoagie, what sort of shape is that going to turn into, cutting from the left and right sides there? All right, if no one's going to wake up, I got to use cards. Andrew, what do you think? What kind of shape is that going to make? It's going to make a rectangle. I agree with that. This is not going to be drawn to scale. What would the dimensions of that rectangle end up being? 4 by 13. So it's going to be 4 inches tall and 13 inches long. So depending on the direction that we cut, they're not really cutting, but that's how we imagine it, we are going to create different resulting two-dimensional figures. So your, I don't even know what to call it, the box down below here shows you examples of each of those. If I slice vertically through an object, I actually have to ask the question, am I going vertical through the front back, or am I going vertical through the left right? Because both of the slices that we just made up there were vertical slices. But we got two different resulting shapes. Because I cut from the top to the bottom, either through the front and back, or through the left and right. Now this cube is a bad example of that, but you can see that one goes one direction, one goes the other. Here, I would use the height and the depth or width of the shape. And here, I would use how long it is by how tall it is.
Actually, I think the cube's a good example because it looks like when you slice down, it looks like it's actually a rectangle when they cut down from the middle of it.
And this might actually be a prism that's taller than a cube. So it doesn't actually tell me what the three-dimensional figure is. So it's either a cube or a prism. So the only differences between a cube and a prism. Didn't realize that we were getting this far today. Gotta get these out. So your cube. Same on every side, right? So if I cut vertically through the left, right, or vertically through the front, back, I'm going to get the same resulting figure. Plastic. So then, if I have a prism, though, check it out. If I stand it this way, vertical slice, I'll get a rectangle. Vertical slice other direction, I'm still going to get the same rectangle. But if I lay it this way, now vertical slice this direction, I get a big long rectangle. Vertical slice this direction, I'd get a square. So you have to be careful with how your three-dimensional shape is laying. And if you at all want to see some more of the blown out three-dimensional figures, these come out. We can look at nets. We can look at all the different sides. So as we get deeper into 3D figures, we will be using these. My materials are your materials, so if you want to play with these, just be careful. And we've got all of the pyramids and everything else over there. The only thing I don't have is a good representation of a sphere, because that's really hard to have a sphere. And then my horizontal slice here, what dimensions am I going to get from the horizontal slice?
Length and width.
A length of how wide it is, and then I actually called this a depth, because as we talk about three-dimensional shapes, they have depth. They're not just, and so I talk about length, depth, and height. You can talk about length, width, and height. I don't care. If instead of D, you use W, I don't care. It's up to you. As long as you know how to describe the different lengths we're going to get based off how we cut. Any questions at this point? Okay. So, moving on here, we have these prisms, and we need to draw the resulting two-dimensional shape from the slice and label its dimensions. So I'm going to help you with one and then release you for the other two. These are all the same prisms. Yeah, it's a rectangular prism because the bottom, if I look at the bottom, it's 12. So this 12 relates to this side. That's your 12. This is your 10. 8 is how tall you are. So we know it's a rectangular prism because all the edges are not the same. And it's a prism because it starts at one shape and ends at the same shape. It's square all the way up, as opposed to a pyramid. It goes up to a point. So when I look at the resulting shape here, well, each of these, I know I'm going to get rectangles because none of the dimensions are the same. But I'm going to try to draw this kind of at perspective. So if you draw a perspective drawing, it kind of looks like it has an angle to it. But we know it's going to be a rectangle, actually. So if I drug this up to here, can you kind of see what I'm trying to show perspective of? Now, I could actually cheat since I have the smartboard. I could draw this right here. And then say instead of that, I'm going to get one that is proportional in size. But what dimensions, Anish, am I going to get from my resulting two-dimensional shape? What was this dimension and what is this dimension?
So you're going to get, I think it's the length of 10.
So yeah, this top part is going to measure 10.
And then I think the depth and width is going to be 8.
Yeah, so then, and we most of the time call that height, how tall it is. So that height is going to be 8. That 8's a little compacted. So try the other two on your own, and I can cheat. But you just need to try to draw a rectangle. The cross section is that two-dimensional slice. So that's why we drew like on the cheese block. What we're really talking about is when I make the cut, at the cut, what shape was formed. So like when Luke Skywalker gets chopped in half, or Darth Maul, sorry, thank you. That resulting, it was like a diagonal cut, right? So, if I haven't watched that in a long time. So if I got cut by a lightsaber right across here, relatively, what shape would that create from this slice?
Oval.
Like an oval, right? The center, it'd be ovular. If I got cut vertically, it'd be a much more complex shape, right? If my leg got sliced off, that'd be a circle. But if my arm got sliced down like this, that'd probably be kind of rectangular. Yeah, but so this is why I'm not going to give you all lightsabers, because then people would start losing body parts. So, Jeremiah H., what dimensions from that middle prism result from your cross section? I'll come back because your mouth is full. Jaslyn. It's all right, so work through it with me. This edge that we can imagine in here will relate to this edge that's up there. What is the length of that edge? So the 8 is actually the height. It's kind of hard to tell in these prisms. This 12 relates to that edge. So that's going to be 12 inches. And then this front edge, the front is normally a bit easier to work with, relates to this front edge. And that's 10. Yeah, that's our 10 inches. And then we know it's rectangular, so the other sides are copied. Jeremiah, do you know the last one?
Yeah. So the depth is 12.
Yeah, my depth is 12.
And the height is 8.
And my height is 8. Notice, how many times did I use my 10 up here?
2.
How many times did I use my 12?
Oh, wait.
How many times did I use my 8?
2.
When I look at each different direction of cut, I will use each dimension twice. If you've used any dimensions 3 times, you've done something wrong. Because one dimension uses width, height. One dimension uses width, depth. And the other dimension uses height, depth. So they each use their own 2 unique things. Any questions here? Yeah, sorry.
So when you slice it, you only have like, when you slice it, it's supposed to be like a 2D shape, and with a 2D shape, does that mean it loses depth, or like
It
just
has
loses-
no depth left. Or, well, it depends. It'll either have no depth left, no height left, or no width left.
Okay, so it loses like something.
It loses one of its dimensions. Yeah.
Okay, yeah.
So, like, this cut is still going to have width and have height. So we lose our depth. This cut, I keep my depth, actually, and I keep my width. I lose my height.
Oh, okay. Yeah.
This cut, I keep my height, I keep my depth, I lose my width. So I'm getting rid of one of the
So
dimensions.
it's just like the way you cut it.
Mhm.
Okay.
And I guess this is worth saying, these rectangles they have shown are bigger than the shape just to show the plane that cuts through it. That's like the tracer of the lightsaber, or whatever you want to think. It's just showing you where it cuts through. That's not the actual size of the plane that it creates.
That'd be like the best thing ever to be a Jedi.
I wanna have a little-
So, I really, and I've hypothesized out how I could do this, I would love to bring in my table saw and start with 3-dimensional blocks or whatever and literally cut and show what's left over at the cut. So if you can imagine, take a 3-dimensional object, run it through a saw, and then look at the face that was up against the saw blade. Both of those faces should be the same thing. So like if I took my water bottle and sliced it through a table saw and I opened it up in the middle, they'd both be circles. But if I took, well, yeah, unless you're a really bad cutter. If I took like this remote and sliced it through and opened it up, they'd be like rectangular type shapes. So just think about that whole operation of cutting. So here, what are the dimensions of our cross-section formed? I like to, whether you can drag it or not, I like to color on the edges just so my brain kind of gets tuned in with what edges am I using. And if this is difficult for you still to see, relate the fact that this front edge is going to be the same as any of the other front edges. And they're all parallel, they're all facing the same direction. So then I can relate that to the value or the length of that edge. Same thing with this edge will be the same as any of the right edges. And I can relate that with the value of the length for that edge. So, Elena, our resulting rectangle that we get here, I'm going to leave my red one there because we would actually just get like a rectangle. It's kind of a poorly drawn rectangle. What dimensions are we going to use, Elena?
So, the depth, I'm pretty sure, would be 6.
Yeah, we're going to keep the 6 centimeters.
And the
Will this plane have height?
I don't really know what to call it, but
So this, if you call this depth, you can call this either length or width.
the length of
Here's the other thing that you can think about. Which number got cut through, that number's gone now. So the edge that got cut through was this edge in the back. That edge of 5 got sliced. It's dead now. It's gone now. So like Darth Maul, if you get cut in half,
You're dead.
you're probably not going to live much
What
longer.
if they sew you back really fast?
Well, that's because lightsabers cauterize, and if you cauterize the wound, it can. Yeah. Let's not go into all the
It
details.
would be impossible to fix a lightsaber wound because it burns. So it would
Look,
close
this is
up.
also because they have the Force. We can't argue the Force in mathematics. That breaks rules. So here's the weird thing, though. let's say I take this box, right? And it's closed, it's just a box. And I want to slice through it. But one of you guys challenges me. I love a good challenge. And you say, I bet I can get a slice bigger than yours. So I've been talking about vertical slices, either front to back, left to right, or horizontal slices straight across. But one of you guys says, yeah, I can get a bigger slice.
That'd be easy. All you have to do is turn it.
What do you, if I turn it like this and slice, I'm still doing the same slice I've done, except instead of horizontal, then it would be vertical.
I know exactly.
To get a longer length, or a longer whatever of your rectangle. If this is 10, and this is 3, the distance from this corner to this corner is bigger than 10. This is our triangle, like hypotenuse theorem, and we'll get to there later. But we know that if I can't go in a straight line, like if I can't go 10 and I can't go 3, the diagonal distance will be more than that. And this actually brings up a really cool relationship that I think I assumed, that you knew. Hi, Saul. This is the Pythagorean theorem. This is our best friend when it comes to geometry. If you'd like to learn more about Pythagoras, go search him. He was one of the Greeks. I think he was a Greek. Yeah, so we don't have time to go deep into Pythagoras, but we can figure out this length.
What if I put the Pythagorean theorem with any right angle?
Any right triangle, yes.
Any right.
So we have our two short legs, 10 and 3. To find the hypotenuse, and I'm not going to test you on this chapter, but you should write this down to get the ideas started in your brain so you know how to do this. We take the one leg, square it. Take the other leg and square it. That will equal the resulting hypotenuse. Hypo meaning under. It is under the right angle. Because I can turn this, so here's my right angle. This edge is quote-unquote under it. If I turn the shape, it can be under. So 10 squared is 100. Bless you. 3 squared is 9. So 109 is going to equal that other leg squared. Here's a branch of the algebraic solving we didn't do much with. Does anybody know what the inverse operation to squaring is? Yeah, Nishiman already said it. Square root. So if I square root both of these, that will give me only C is whatever radical 109 is. You got it? Sorry, thought somebody had it. Radical 109, and we get 10.44. So that will tell me the length of this edge. So I'm going to just draw a small rectangle out here. So we know that the long edge will be 10.44. What will this edge be?
3.
No, 3 is your height. That edge is your depth. It's going to be 2.
Mr. Hudson,
Yes?
I realized, so for next year, for your next accelerated 7th class, you can just have them watch videos the whole
I know, but I mean, that's not my plan. I kind of dabbled with a plan like that, but then a lot of feedback that I was given was that the live show was better and more enjoyable than just staring at a screen. And we don't want you guys to have that much screen time in your lives. So I still like teaching when possible, and sometimes incorporate the blended just to get through things quicker, or make sure you guys understand it all. Or yeah, the main reason I record is for when you guys miss out because being sick or whatever. Yeah, I am not anywhere close to a revenue point yet. So, I want you to draw these on your own. How would you draw a horizontal cross-section? And then how do you draw a vertical cross-section? And you need to make your choice with vertical. What direction are you going? Are you going front to back? Or are you going left to right? So we're going to have 2 different options here. So draw these out on your papers. Horizontal, you don't have an option. Horizontal is horizontal. I can turn it and it's still the same thing. Vertical, my rotation of what direction matters greatly. Now, here is a trick to geometric drawing. And if you're working in pen, I apologize, but if you're working in pencil, this is perfect. When you're drawing edges that you can see, I can see the front edge, so I can draw it solid. I can see the right edge, so I can draw it solid. And here's the trick. You want this edge to be parallel, so it's going to have a little bit of angle. But now, can I see through a three-dimensional object? Probably not if it's a solid. So the back, I can't see. I use a dotted line. Sorry, my dotted line's not very good because I was going the wrong direction.
What about glass?
Yes, I get it. You could potentially. But I'm teaching you how to draw in geometry. If you can't see through it, you use a dotted line to represent it's on the other side of the solid. Yeah?
How do you tell which side is which? Because every time
The side that faces you is front.
I know, but I can't really tell because every time I move, it seems like
Oh yeah.
it seems like the shape is shifting.
So, you're having issues based off the fact that your brain's not yet identifying the dotted lines. The dotted lines in the shape tell you what's what. The front box here has all solid lines. That's your front. You can see it. This right side has all solid lines. I can see that. So if I think about looking at something, I've got a cube that I can see the front, see the right, and see the top. But when I have this cube like that, I can only see those three faces, and really I can't see through it. So now the faces back here, I can see this edge, but I can't see any of the other edges. That's why they're dotted. So that's how you need to get your brain to kind of switch and say which is your front based off which face is solid.
Yeah, I see it too. Like every time you look at it,
Yeah. And that you'll get better at that as you do more with this. A lot of what I have you guys doing on your homework is not necessarily thinking about the slices, but thinking about the different views. So if I view something from the front edge, if I view it from the right edge, and all of those are labeled, it'll say like front, right, top, or like they'll have labels on the shape to help you out with that. So with my vertical cross section, if you went front to back, if you went FB, front to back, not Facebook, I can start on the front because I can see it. I can then go across the top because I can see it. I dotted line my back, I dotted line my bottom, and there's my cross section from front to back. If you went left to right, I can go across my front because I can see it. I can go across my right because I can see it. I cannot see my left side. I cannot see my back. I'm sorry that my lines are not great. I can't use a straight edge up here, but you guys can if you would like. Any questions on drawing those? I know this is a weird skill to get used to. We'll look at pyramids tomorrow and do more practice with this. We got time, but I'm just making sure we're okay right now. So, think about this. Draw and label the cross-section formed by a plane that slices the cube as follows. So it's now describing the 2D plane. So this tells me the plane is vertical, standing up, and intersects the left and right faces. Try to draw that on your own. You can reference back to what's on the TV if you need. Wait. You guys excited for Friday Creative Auction Month? I'm super excited. Anyone sign up for Marth? So, this is with the whole like teachers spend their own money stuff. I bought these on Amazon. These are adult coloring books, but they are like mind blowing. The things in here, like this is all golden ratio created. So if you're talking about your eyes playing tricks on you, these books, and you don't have to be Marth to look through these. I can copy these since I'm a teacher. I'm allowed to make copies. So if you are somebody who's like mastered, or you want something to take home or something, if you want some cool mathematical things for coloring, feel free to come check out my books. And it tells you about it. So it tells you the math of how was this formed, what math is in it to make this crazy shape. This one will like totally trip you out. It's called Visions of the Universe. They have all kinds of different like ways that you can think about the universe being formed in different perspectives. So if you want to work on your drawing techniques, and then there's some in the back that you have to create on your own. And then you guys have probably heard a little bit about fractals. So this is all about different fractals, and you can color in those fractals. Huh? Oh, yeah. I know, it can. Like, it was giving me a headache when I was looking through it the other day. Yeah. Anyone confident enough to come do A? Ooh, Dom? Haven't talked with you yet today. That's a good attitude. Anyone confident enough to do B? I haven't talked with yet. Sean, we barely talked. Never mind. Default to a girl. Honestly, you want to do it? So, hold on. Is that red plane vertical? So hold on, Mom. So actually, dude, that is going this way. That's the horizon. So what Dom actually just did. You got it? Can I help you? You're using too much fingernail. I'm serious. If it picks up your fingernail, it thinks you're trying to use a pen. So, Manasa can actually get our vertical plane, which has to go up and down. So please change that on your paper, sir. Make sure that vertical is up and down. And it intersects the left and right faces. So that's why it has to actually be running through the shape side to side instead of through the shape front to back. It is very hard to draw on smartboard, and it's very hard to copy lines of a 3D shape. So that is a good representation. Actually, a trick that can get messy, sometimes you just need to darken up and thicken up your lines. So if I like darken this up and make it a little bit thicker, darken that up, that looks a little, I don't know, they're kind of straighter now. But yeah, that's perfect where she drew it, going left and right. So now we're back to our block of cheese. Sorry, questions? Huh? Well, oh, sure. So we're back to our slice or our block of Velveeta. So draw and describe the cross section, the vertical plane that slices front and back faces of the prism. If you already know it, come on up. So, interesting question, Jeremiah.
Yes.
Circles, if I think about slicing a circle, what would a sphere. So think about a sphere, like basketball. If I slice it vertically, what am I going to get? Circle. If I slice it horizontally, what am I going to get? If I slice it diagonally, what am I going to get? So a circle, no matter what direction you slice it, will result in the same, a sphere, no matter what direction we slice it, will always result in the same exact circle, which is cool because that's easy. As opposed to any other shape, we have to think kind of hard. Jeremiah?
Wait, so if you get a basketball and slice it like this, then you get two halves of the basketball.
We're talking about the plane that is created. The slice where it slices is a circle, like what it had to cut through. If I do vertical, it's still a circle. If I do horizontal, it's still a circle. If I do diagonal, it's still that same circle regardless of what angle, because it's a sphere and it's a perfect circle, like all the way around, same distance from the center, we'll get the same circle, regardless of where we cut it. And this is perfect through the front and back vertical plane. Any questions on that? So now, ponder. Sorry.
When you're looking at a shape like that, how do you know which is the front?
So, again, it will be labeled on your homework, but the front is the closest face to you. So if you imagine this coming out of the board, if it was actually 3 dimensions, this would be sticking out like this, kind of at this weird angle. This is the closest thing to me. Once I reference front, if I'm looking at that face, we have right, top, left, bottom, and back. Once we know the front, then we can figure out all the other sides by looking at it and giving it our perspective.
The front's normally like the one going down.
The front's the closest to you. It's always, so, like, Here's the back, because it's dotted. You can tell that's far away. I can't see any of this. The one I can see all of and is closest to me is this one. This face, I can see all of it, but it's not the closest to me. That's actually the right face. So ponder this for a second. I've got a cube, and now, again, because you middle schoolers are so crafty, somebody says, I bet I can get not a square, not a rectangle when I slice through this. So if you've already read the next question, you know where I'm going with this. Ozzy, what kind of slice are we talking about? A diagonal. So imagine this. We have a cube, and we slice through it through the top and front. Sorry, if we want to say if this is your front facing closest to you, we slice through the top, the front, and the right side. So we're slicing diagonally like this. If we have this edge, and actually, because we have just a couple minutes left, I want you guys to all try to draw a cube. So if you've never drawn a cube before, I'm going to zoom in a little bit so I have more space to work with.
Can I do it?
To save time, we gotta hurry. So first, start with a square or a rectangle, whatever you want to start with.
Lap a square over a square, and then put the connect the edge.
Then, and this is where it gets dangerous if you don't use dotted lines. So Jeremiah was saying, lap a square over a square, like overlap them, right? I can, but now we're ignoring that anything would have dotted lines, and that's okay. Then all you have to do is connect the corners. And then with you using a pencil, you could go back and erase the lines in the back. So I could dot these lines, and I could dot this line, and then I could dot this line, because I can't see any of those, technically, quote unquote. But if I cut the corner off, I cut through the top, through the front, and through the right. What's that resulting cross section? A triangle. And it would actually, what were you about to say? It would cut off a triangular pyramid, but when we're asking about the cross section, we just want what shape did it leave when it cut, which was a triangle. So my resulting triangle would be something like that, where this came from the top, this came from the front, and that came from the right. It depends on how you make the cut. Because think about how many different angles I could cut at. I could cut like through the middle here, but through the corner here, down to the corner there, and down to the corner there. So these two legs are not the same size right now, but if I go corner to corner, I could make them the same size, cutting diagonally like this. Like if I cut the square kind of in half, and then just down to the one corner, then I could get a special type of triangle, but it all depends how you cut. It's all angular.
We'll have the different types of pyramids. There's a square pyramid, a triangle.
I got a bunch in there. I have like a hexagonal pyramid, or hexagonal, depending on how you want to say it.
Bunch of them.